Okay, hello students. Today again we are coming with a new video on conservation of linear momentum. Okay, today what we are going to discuss, it is conservation of linear momentum. Okay, please write the headline of today's topic. It will be conservation of linear momentum. Remember, in later we are going to discuss the conservation of angular momentum also. And I hope you have all of you understood the momentum. No, it is the product of mass and velocity. Okay, and you know the velocity vector quantity. Hence, linear momentum also will be a vector quantity. Okay, guys, and just what is the law? We are going to first discuss the law. Okay, the law says that in the absence of external force, the linear momentum of a body always remain constant. And remember, the force is a vector quantity, momentum is also vector quantity. So force, in which direction force is zero, linear momentum in that direction will be remain constant, means it will not change at all. Okay, just we are going to prove it also, but you have to learn this definition. It is very important definition, so you better learn it and repeat. I just want to repeat it. In the absence of an external force, remember external force, they are not talking about the internal force. Okay, the linear momentum of a particle or a system of particles, means you can say body, remains constant unless and until apply you one external force. The linear momentum cannot be changed. Okay, and this is called law of conservation of linear momentum. Okay, and I'm sure you are writing also na, with me. So let us prove it. Let us prove it. How to prove? Let us prove it first. Okay, see, the product of mass and velocity, what it is? The product of mass and velocity, we call it linear momentum. We are talking about the linear velocity, hence it is linear momentum. Now, if I want to convert it into kinetic energy, what I get? The magnitude of linear momentum may be written as P equal to mv. So if I squaring both sides, if I square both sides, P square is equal to m square v square. Just I am going to design something, nothing else. Okay. Then what I am doing here, in this term, I am putting at multiplying the term with 2, and to nullify it, dividing also by 2, so that the value of the term does not change. But from that, what I have got that the term inside the bracket, it is becoming the kinetic energy. Okay, it is becoming the kinetic energy. So P square, linear momentum square, is equal to 2 times the product of mass and kinetic energy. Okay, you are going to get this relation also, because it is also very useful relation to solve lot of problems. From this formula also we get uh, some numericals to solve. Okay, okay guys, just a minute. Okay. So from that expression, what I get? From this expression I get P is equal under root of 2mk. P is equal under root of 2mk, or k is equal P square by 2m. If linear momentum is given, kinetic energy can be calculated, or if kinetic energy can be if kinetic energy is given, momentum can be calculated. So this equation, I think some of you have already learned in class 9 also, no problem. But we need to know some utility of this expressions. Okay, that is very important, very important problem. Okay, I hope you have learned it, and later we are going to solve some problems, so you have to learn it. Now you see, in accordance to Newton's laws of motion, basically we are going to use the that on second law. So what I get from the second law, I get F is equal to ma. Okay, F is equal to ma means this force is equal to mass into rate of change of velocity. It is nothing but the rate of change of momentum. Yeah, you can directly write uh, rate of change of momentum is equal to the net external force. No? It is actually directly proportional, but proportionality constant comes out to be 1. That is why we write external. Remember, this is the external force. Huh? This F is the external force, not internal. Okay, and it is a vector quantity. And here it is momentum is also a vector quantity. If you write Fx means force along x, so you have to write dpx means momentum change along x. Are you getting my point? So from that expression, we got the relation of force and momentum. Okay, this is the basic relation of force and momentum. Now you see, if the external force is 0, what will happen? If the external force is 0, I get the rate of change of momentum is also 0. If the external force is 0, it means rate of change of momentum is also 0. And remember, that dp dt is 0. So what will happen? What is the physical significance of dp dt is 0? Okay, if p is constant, then only the differentiation of that quantity is 0. Na? So hence directly mathematically we can write p is equal constant. Directly we can write p is equal constant. If force is 0, it means dp dt is 0, and dp dt will be 0 only and only p is 0. Sorry, p is constant. No? When momentum is constant, then only its differentiation with respect to time will be 0, because it is not changing. How can you differentiate it? Are you getting my point? So very good. So this is the main expression what I have got, means if the sum of all external forces is also 0, then say a lot of forces are acting on the particle. There may be a lot of forces, na? But if I get, if the uh, sum of all external forces equal to 0, sum of all external forces, say we have a lot of particles in the body, okay, yeah, in the system, there may be different forces, F1, F2, F3, Fn, like that. But if sum of all the forces equal to 0, it means momentum of the system, say n particles are there. So momentum of P1, momentum of P2, momentum of P3, momentum of Pn, all sum of all momenta will be constant. If one is increasing, other may be decreasing, so that their sum remain constant. Are you getting it? Very important expression. Very important expression. Remember, this is constant only when the uh, external force, net external force on the particle is 0. Very good, guys. I hope you're copying also all these things with me. Okay, if required, you can give the pause to the video and easily you can copy. So why don't you do one numerical? Okay, whatever we have discussed, out of which you can make one form in numerical also. Let us discuss this numerical. Okay, what does it say? And I'm sure it is visible to you. It says that linear momentum of particle is increased by 100% without changing its mass. Find the percentage increase in its kinetic energy in both the cases. In first cases, we have increased by 100%. In second case, we have increased by 1%. Remember, it is 1%. It means we are increasing very less. Okay, we are increasing it very less, and it is 100%. More than if it is more than 5%, we have to say that the increment is sufficient. If it is less than 5%, we say that the increment is very less. Okay, guys. Okay, in future also you can just when you ask for a hike in your salary to the boss, okay, you can say that please you just give the increment at least more than 5%. Okay, okay, guys. No, you can get more than 30% also. You deserve it. Okay, you just hard work, continue your momentum. Okay, then obviously you will get it. Okay, guys, don't listen to the bog. You just try yourself and then give a pause to the video and do yourself. And later you try to compare with my solution. Okay, but I have to give the solution because time constraint is there. See, let me discuss the first question. Okay, where momentum is increased by 100%. See, we know the relation between kinetic energy and momentum is this. See, momentum is 100% increase, so kinetic energy will be increased. Mass is not changed given. So this equation will be a very fruitful equation for us to solve our problem. Okay, good. So how can we solve it? See, if I increase P by 100%, it means our new momentum will become 2P. P is increased by P. So P plus P is automatically becoming 2P. So now in our new kinetic energy expression, why don't we put 2P? Okay, let us put 2P. This is our new kinetic energy expression. This is our new kinetic energy expression. So new momentum square divided by twice of mass. Okay. So in place of P dash, you are putting 2P. So it is becoming 4 times P square by 2M, and P square by 2M was the initial kinetic energy. It means our kinetic energy increased 4 times. Remember, our percentage increase will be discussed later, but this may also be a question. This may also be a question. What will be the new kinetic energy? Are you getting it? So your answer will be that one, uh, 4 times. Okay, guys, very good. Now let me discuss the second part. Okay, how much the percentage increase is there. To discuss the percentage increase, we understand the percentage increase is nothing but the final value minus initial value. It will give you the change. Final value minus initial value, it will give the change divided by initial value. As a whole, it will be the fractional change. Okay, into 100 means your percentage change. Are you getting it? So final value minus initial value, it is the change divided by initial value. The whole will be the fractional change into 100 means your percentage change. Okay. Now, just what you need to do, you just put it on your equation. Okay. Final kinetic energy was K dash. Initial was K by initial K into 100, but final kinetic energy is calculated to be 4K. 4K minus K divided by initial K into 100. So it is coming out to be, guys, 300%. In most of the cases, students make the mistake as it is increased by 4 times. Now it increases to 4 times. Student immediately say that 400% is increased. That is very wrong, very wrong. It is increased by 300%. Okay, very good. Now, why don't you go to the second question? What is the difference between this question and the second question? You see, in the second question also, we can write kinetic energy. We need to calculate the kinetic energy only, na, from momentum. So, we know kinetic energy is momentum squared divided by twice of m. But now we can use a small technique. I am sure in our basic mathematics classes, we have discussed all these things and you understood also in this. Huh? If there is a small amount of change, from this expression only, directly you can say, you see, kinetic energy is equal P square by 2m. And 2m is constant. It means kinetic energy is directly proportional to P square. This term is very important. What is the power here? 2. It means if momentum is increased by 3%, the kinetic energy will be increased by that power times the percentage change. It is 2, na? So 2 into 3% means 6%. Okay, I think you can recall it now. If it is P cube, na? So it will be 3 times. If it is P to the power 4, it will be 4 times increase. Okay, like that. But remember, this validity of this question is that the momentum should be changed. The momentum change, yet the change in this quantity should be very less, like 1%, 2%, 3%, up to 5% you can. But otherwise, now you have to go through this technique only. This is the general method. Okay, this is the general method. You have to go to with this general method only. Okay, but if percentage is less, you can use a very shortcut technique also. Okay, guys. Uh, So what I said, if it is p square, it means 2 times. If it is p cube, then 3 times. Okay. Say what is the volume of a sphere? Volume of a sphere is v is equal 4 by 3 pi r cube. 4 constant, 3 constant, pi constant, r cube means volume is directly proportional to r cube. So if r is increased by 2%, volume will be increased by 6%. That power will come as multiply. Okay, 3 times. Okay, we can use this type of techniques to solve this type of problems. Okay, so now I am sure you understood all these things. Directly you can copy the answer also. Now you see that the thing whatever I have said I have written. Okay, if the power is 2, so it will be just 2%, 2 times the change in percentage in p. You can note it down also, very important. So just verbally you can solve this type of problem. This type of problem can be, because you see here it takes lot of time also and calculation also in if you go with the general method. But one more thing, if you do the same problem, this problem, second problem with this general method, then of course you are not going to get exactly same answer. Okay, you are not going to get 2%, you are going to get like 2.00001%. Okay, but we can assume that it is also 2%, no problem, because percentage change is very less. Okay guys, good. If you left to copy, then just give a pause to the video and just copy, because you have enough time. Okay, now okay, come to the second problem. Come to the second problem. It is almost similar but just reversed. Initially I have given p, I asked to calculate k, but in this problem I have given you k, you need to calculate p. Okay, and I'm sure you will give a pause to the video and solve the question. Okay guys, okay, try it, give a pause to the video. But for me actually it is very difficult to wait to save the time in YouTube video, so I am solving it, and I hope you have tried and you found the answer also, just ready to compare the answer with me only. Okay, now actually I have taken this problem because k is given here, p is to be found out. Okay, p is equal to under root 2 mk, yeah, km. Okay, whatever it will be. Okay, now k, it will be k to the power half if you need to calculate the percentage change for very small amount. But for 50% it is a large amount. Now we have to go with the general method only. Okay, kinetic energy increased by 50%. 50% means if it is initially k, now k by 2 will be added to it. K by 2. If it is increased by so k plus k by 2 means what? 3 by 2 means 1.5k. 1.5k. Are you getting my point? Okay, very good, very good. Okay, then let me come to the second part. Okay, so the new momentum will be under root 2 times k dash m. So new kinetic energy, so that is why you put the value of k dash now, because k dash is 1.5k. K dash is 1.5, so it will become like this. If you bring out the 1.5, under root 1.5 is coming out, so it will become under root 1.5 times the under root 2 km, and that 2 km is nothing but the initial momentum. Okay, and under root 1.5 is almost 1.22. It means new momentum will be 1.22 times the old momentum. Okay, this may be also asked. See, okay, you may be asked this question also. What will be the new momentum with respect to the other momentum? Now we just go with the general, because we are asked to calculate the percentage change. So what is the percentage change? Final momentum minus initial momentum divided by initial momentum into 100. So final momentum is 1.22 p and initial momentum is p. So cut down all these things and you are going to get 22%. Guys, you have a big thumbs up if you have done it correct. Okay, good. and then you try to solve the B part. Okay, before I do, try to solve the second part. And I have already told you that the under root k means it is k to the power half. No? So given you the clue also, no problem. Okay, see, P is equal under root 2 times km. So I can write that P is directly proportional to under root k. It means P is directly proportional to k to the power half. In the previous question it was square. Now it is half. In the previous question it was square. So it becomes 2 times the percentage change. Now it is to the power half. So it will become half times the percentage change. Okay, simple. Simply directly you just do it, nothing else. Okay, so it will become the half times the previous change. Okay, very good, you guys are doing very good. Okay, and you just try to comment on your video also, guys. You people don't comment on the video. Okay, and also give me the notes whatever written. Definitely you have to submit back, then like a obedient student. Remember, though I can see you at present, but my heart is with you, and I feel your presence. Okay, whenever you just go through my videos, I feel that. Are you getting my point? So just to realize that feel, you have to keep in touch. You just keep on sending the notes to me. Okay, just I am expecting that you are seriously you are practicing all these things, and just you can request me also what to discuss. Okay, these are some basic steps. Remember, we are discussing the very uh, the basic level problems, which is very much required for our preparations, either for JEE or for medical or whatever it may be. Okay, this type of competitions. Okay, guys, I hope everybody got it. That is 0.5%. If you are getting it, then big thumbs up for my side. Okay, guys, very good. Okay, let us try some another problem. Okay, just from conservation of momentum also we can take one problem. Okay, very good. Okay, guys. Sometimes the screen disappears. Okay, this is the good question. See. Go through the questions. Question is, two blocks A and B of masses 1 kg and 2 kg are connected together by means of a spring and are resting on a horizontal frictional table. Blocks are then pulled apart so as to stretch the spring and then released. Find the ratio of their speed. Okay, magnitude of momenta. Okay, and kinetic energy at any instant. Okay, that is the question. Try to visualize the picture, guys. Try to visualize the picture. Okay, frictionless table. Okay, there are two masses. Okay, okay, guys. Okay, and they are connected by one spring. No? Okay. Okay. I'm very sorry. My handwriting is very bad. Okay. Then that is say it is 1 kg, and this is say 2 kg. Okay. You just draw it with me, because I have to erase it. Okay. And what I have done, pull apart. Uh, okay. And then released. Remember, after releasing, no force is applying, because surface is frictionless. So that is external force is 0, and we cannot consider the spring force because spring force is becoming internal force here. So external force is 0 here. So we can apply whatever we want. Okay, conservation of momentum and all we can easily apply. Okay, guys, and I hope at least you have calculated any one of these, or just give a pause to the. You don't forget to give the pause to the video. Okay, just for the sake of saving time, I keep on doing, but for you, you have to give a pause to the video. Okay, let me calculate this. I know that external force is zero, so momentum, net momentum must be zero, because initially it was rest, na? So initially it was rest, so it means momentum of the system was at rest. Okay, the system has zero momentum. So finally also momentum must be zero. Say this is P1 momentum, that is P2. So P1 must be minus P2. So P1 can be written as M1 V1 and minus P2 can be written as M2 V2. So what does it mean? It means if it comes this way, it will go this way. Okay, just there nothing else. After releasing, if it comes this way, it will go this way. Their momentum is opposite. That is why this negative terms coming. The negative that's coming for that purpose. Nothing else. Okay, guys, just solve it. You put the value of masses and all. You are going to get the answer. I think ratio will be 2. Okay, put the value of m1 as 1, m2 as 2. Okay, then magnitude of velocity, it is nothing but the speed. Okay, the speed ratio is 2. It's very good question and easy question. Okay, then second part, magnitude of momentum. Check it, check it, check it. Just verbally you should answer it. Magnitude of momentum, verbally you can give it. I've already told you that momentum is equal. Okay, because external force is zero, the momentum must be equal, and opposite also. So the net momentum becomes zero because initially it was zero. Initially the system was at rest. That is very important. Remember, initially the system was at rest. If we imagine a situation, the system was moving uniformly, say, okay, and during the motion I have pulled them apart and released. Remember, then this term zero will not be zero. It will be the initial momentum, whatever we have seen. Okay, yeah, we have given. Okay, guys, kinetic energy. Try to calculate the kinetic energy at any instant. Ratio of kinetic energy, in fact, we need to calculate. Okay. So what I need to do, we need to calculate that, find that relation only, nothing else. Kinetic energy and momentum relation. Kinetic energy and momentum relation is this. Okay, p square by 2m. We can put it here and just find the ratio of kinetic energies. Okay, k1 by k2. Are you getting? Because kinetic energy is directly proportional to p square by m. 2 is constant, so it is not required. So p square by m, it means that is p1 by p2 whole square divided by is 1 by m is reciprocally proportional. So m2 by m1. So if I put all this value, we are going to get 2. Okay, guys, very good. You people are doing very good. Okay, so and I'm sure just again a big thumbs up from my side if you have done it well. Okay, you have got the answer properly. Then I think this is the last question. Okay, just also attempt it. This is the question. Okay, take this. Let me clear all the drawings. Okay. So this is my question. A gun of mass m, that is very popular question also, fires a bullet of mass small m with a speed v are relative to the barrel of the gun, which is inclined at an angle 60° with horizontal. The gun is placed over a smooth horizontal surface. Find the recoil speed of the gun. Are you getting it? So that is so let me draw the figure first. Then it will be very easy to understand. This will be the figure. Okay. So this is the barrel of the gun. Bullet is fired with relative velocity v. Remember, this is not the actual velocity. This is the velocity with respect to the gun. So in this type of problem, remember, we have to move very precisely. First of all, we have to calculate the actual speed of the bullet. That is very important, because in our equation of momentum, say final momentum equal to initial momentum, whatever velocity we have written, That was the actual velocity. That was not the relative velocity. Okay. So this is a very common question. In this type of problem, what you do is really, uh, first let us assume that the gun recoils, yeah, that cart recoils with velocity v. That is assumption. Okay. Now you see, the velocity, it is at 60 degree, na? That is 60 degree. So this component will be Vr cos 60 and this component will be Vr sin 60. But remember that Vr sin 60, it is also relative. Vr cos 60, that is also relative. Okay. But what will be the actual velocity? See, frame is moving back with velocity v. So its actual velocity will be Vr cos 60 minus v. Okay, we have already discussed in our relative velocity part. Are you getting my point? Now frame is moving back. If frame is moving ahead, na, so you will have to add it. Okay. But what about this Vr sin 60? We do not require it at all because we are going to conserve the momentum, linear momentum along the horizontal direction only. It is not required at all. Okay. But again, if I ask you, I can say that this is also the, we can say this is also the real velocity because ground has no any movement along the vertical direction. The object has, the frame has no movement along the vertical direction. So this is Vr sin 60. You can say relative also as well as the actual also. But the horizontal component, which is Vr cos 60, it was not the actual, it was the relative velocity. We have to make it actual. We have made it Vr cos 60 minus V. Okay, guys, good. That part is very important. Now let me apply the conservation of momentum. You see, before firing the bullet, the linear momentum along x-axis, the linear momentum along x-axis, say this is the x-axis, it was 0 because it is stationary, no? Because it is stationary. So after that also it will be, it must be 0. Okay. But after that, there are two momenta. One is the momenta of the bullet and second is momenta of the gun. Are you getting? So what I need to do, I have to put this. Say I am assuming the left direction is positive. Say left direction is positive. So what I have written, so that is mv. Okay, I am assuming left direction is positive. Now I have to write plus the momentum of this, but this direction is negative now. So that is why I have put minus. Okay, mass of the bullet and its actual velocity, that is the actual velocity, Vr cos 60. Okay, equals to 0. Are you getting, guys? Good. Now just you solve it and find the real answer. What is the real answer? And those who have already done it, just compare with me, and the real answer is this. Okay. Are you getting it? And they will give the value of Vr, so you can put it, but they have not given the value. We have to write the answer in terms of that only, nothing else. Okay, in terms of Vr and Vr cos 60. Okay, guys. So this is the today's discussions, and I will come back with more videos with more problems. Okay, so just keep liking my channel, subscribe my channel, share with your friends. Okay, and whatever requirement you just give in the comment box. Okay, guys. Nice. Thank you.